So the next thing we want to talk about with our matrices, now that we can identify them, is I can actually perform specific operations on the matrix, such as addition, subtraction, and what we call scalar multiplication. And I'll explain that a little bit further in just a minute. So if I have matrix A here and matrix B, I'm going to perform these three separate calculations to each of these two matrices. So first of all, how do we add matrix A with matrix B? So if I'm looking at matrix A plus matrix B, what I'm looking at is, and I'm going to do this kind of the longhand way the first time, I am simply adding each of their corresponding elements together to get a new value in that position. So here in row 1, column 1, I have a -2. I'm going to add that to matrix B, row 1, column 1, which is an 8. And I'll total that up in just a second. Moving to the next spot, I have 3 plus 1. Coming down here to row 2, column 1, I have 0 plus its corresponding spot for B of 5. And row 2, column 2, which is a 1 plus row 2, column 2, or a 4. Okay, so I'm going to sum these values together and get new values in each of these positions. So row 1, column 1 becomes 6. Row 1, column 2 becomes 4. Row 2, column 1 is 5. Row 2, column 2 is also 5. So when I add matrix A plus matrix B, I get the new matrix here that you can see. Okay, so what happens then if I subtract A minus B? So I have matrix A minus matrix B. And I'm not going to go through the long-handed route, but it follows the same process. Each element from A subtracts each element from B. From B, yeah. So if I have row 1, column 1 minus row 1, column 1 here, so that's -2 minus 8 would be -10. Here I have row 1, column 2 minus row 1, column 2, so 3 minus 1 would be 2. Moving to the second row, 0 minus 5 would be -5. And here I have 1 minus 4, which would be -3. So I have, using subtraction, a new matrix here. Before I go any further, let me remind you that just like operations add, subtract, multiply, and divide with real numbers, addition is commutative, meaning that if I add A plus B, that's the same thing as adding B plus A, right? Because 3 plus 5 is the same thing as 5 plus 3. They both give you 8. Now, subtraction, however, is not commutative. So 3 minus 5 is not the same thing as 5 minus 3. Okay? So just like in real numbers, addition is commutative, subtraction is not. Now, what are we going to do when we talk about this last operation we're going to perform on these two matrices? So here I have 3a plus 2b. When I multiply a real number times the matrix, that's what we call scalar multiplication. So this says that I am going to multiply every element in matrix A by the number 3. That's called scalar multiplication. And I'm going to add that to 2 times every element in matrix B. So let's kind of step through this a little bit slower. If I have 3a plus 2b, first I'm going to say, well, 3 times matrix A, which is -2, 3, 0, 1, and I'm going to add that to 2 times matrix B, which is 8, 1, 5, 4. Now, 3 times each of these 4 positions gives me 3 times -2, which is -6, 3 times 3, which is 9, 3 times 0, which is 0, and 3 times 1, which is 1. So that is scalar multiplication of a single matrix. Now, what happens when I multiply 2 times matrix B? I get 2 times 8, which is 16, 2 times 1, which is 2, 2 times 5, which is 10, and 2 times 4, which is 8. And that is scalar multiplication times matrix B. Now we can finish our operation by adding my new matrix on the left with my new matrix on the right. So each position is added to its corresponding element. So negative 6 plus 16 would be 10. 9 plus 2 is 11. 0 plus 10 is 10. And 1 plus 8, I didn't multiply right, did I? Oh, I hope you caught me in that. This should be 3 times 1, which is 3. So 3 plus 8 is 11. Okay, so hopefully you followed that mistake I made, but when I added 3a plus 2b, I ended up with this new matrix 10, 11, 10, 11. And that's how we can perform operations on our matrices. And this was doing it on a 2 by 2 matrix for A and a 2 by 2 matrix for B.